are going to be learning about WaterCAD today. I use WaterCAD to design pressure pipes. I'm a land development engineer and I use this to design all of the water main, the irrigation mains. Sometimes you might even have some raw water mains from wells, and then last but not least, even force mains. So let me kind of dive in here. Here we are, we're at the welcome screen. We're going to do create new hydraulic model. So now we have our model open, and for this first kind of thing I'm going to do, I always like to set up different scenarios and alternatives. I want to, kind of organize myself and start thinking about, what this is going to be named. Right now we just have a scenario called base, but I'm just going to change that here. We're just going to do phase 1. Phase 1. Let's do water main. Phase 1 water main. We're going to build phase 1 of this water main. That there is a scenario that I've just created. Now, I like to think of scenarios and alternatives as kind of like a cheeseburger. So the scenario is an entire cheeseburger. And within a cheeseburger, you have toppings. That is where the alternatives come into play. So the scenario is the cheeseburger. The alternatives are all of the toppings. It's your, lettuce, tomato, mustard, whatever you want to put. That's the easiest way that I can explain it. So when you're looking at this scenario over here, and again, I did that by right-clicking over here and I went to properties. So here you see you have all of these different alternatives here. And right now, it's just all base. So I want to go and actually find where all these are. If you go up here to that home tab, click alternatives, and here you have your entire set of alternatives. And I don't want to get too far into this, but let's say if you did have some different alternatives that you wanted to run. For instance, some counties require you to design for the peak flow. So I'm going to create a demand right there, just call it peak flow. Now I can either duplicate, or I can even do a child of this type of alternative. Since I haven't really done anything to it, I'll just duplicate it, and I'm just going to call this something different. Maybe average daily flow. Not the peak condition when everyone's turning on their showers and doing all the dishes and all that. It might not be the peak, but it'll be the average daily flow. And now we've created two different alternatives within a demand property. Now let me show you a couple other things on here. I mean, you have what's called physical. And if you look into what these different things are, physical has to do with the physical properties of a pipe or a junction. But if you're a beginner, we'll get into all that stuff. For now, I'm going to actually just kind of make it easy and just show that we have a couple different alternatives going on. So I'm going to go back to the scenario tree, and since I created two different alternatives for demand, I can actually choose whatever this cheeseburger has. So I can either use the average daily flow in here, or I can use the peak. But again, I haven't really created any demands yet, and we will get to that right here soon. For now, I'm just going to call this peak flow. One of the cool things about this program is you can actually show a background layer. So we're going to set an actual background layer here. I'm going to do new, and you can either assign a DXF file from a CAD DWG. If everyone's familiar with AutoCAD, you can go right into AutoCAD and export a DXF file. That's how you can get some line work in here. But for now, I'm not going to be showing any type of DXF file. I'm going to use a Bing map. And what you can do with this Bing map is you can actually go to a real place. I had a latitude and longitude already picked out, and that's all you're going to enter here in this control point 1. So again, what I did there is I just did a map alignment just to one control point. Map style, sure, I'll just do the aerial for now. Let's do that, and let's see where it takes us. Check this out. We got a little neighborhood. Ooh, so this is my bread and butter. I help design neighborhoods. And what we are going to do is I'm going to show you how I would build just, a conceptual water main model. This is going to be very, very simple. I'm not going to build the whole neighborhood, but I will do a section from this roadway here and through these roads and up along this road. So in order to actually set this thing up, I want to go over here to the Layout tab. Now in the Layout tab, you have all of these fun items that you can use. For this purpose, how I'm going to lay this out is I'm going to use a reservoir. Now there are two different ways to model a point of connection to an existing pressure pipe system. I'm only going to show you one very simple way to do it today. I'll get into the nitty-gritty of a reservoir and pump later, but for now, I'm going to model a point of connection. And in this case, we're just going to throw a reservoir. Think of the reservoir as a certain pressure that you're tying into. I can actually set an HGL, or hydraulic grade line, of this reservoir. So I can actually simulate a static pressure. And again, this will just be a static pressure condition. I'm going to go ahead and actually just place that reservoir right there. Now I'm going to kind of show you what you can do. You can actually play around with all of these different labels. So let me go to this reservoir. I'm going to right click and go to the properties. I want to make this a little bit bigger. So let me do 10. Okay, perfect. Yeah, that got way bigger. That is perfect. I don't want to zoom too far out because these things start going crazy with the aerials. So we got our reservoir in there. And now I'm just going to start laying out pipe. So I want to zoom out here. And like I said, I wanted to build this thing from that reservoir and just kind of hook around into this road. So let me grab my pipe that I have. Let me click that reservoir where our point of connection is. And you see how it's starting to draw? So one thing that I can do is I can go around and click around here, and I'll show you how this is all laid out. Now one little trick is that if you hold the control button and click, you can actually make bends within the system. So right now it's not laying out a junction. Now I'm releasing my hands off the control and I'm going to click, and you just saw there that I created a junction. I'm just going to keep going in control clicks because I just want to bend around here. I'm thinking that this water main is doing something like this. And at the very last end of the run, I'm going to do a junction. So now I press escape, and now I'm cooking with fire here. I just laid out some pressure pipes. Now you can't really see them. I want to increase, some of these junctions, kind of like what I did with the reservoir. So if you go over here to your element symbology, let's see what we got here. So we got junction. We can go to properties, and let's set this guy to, let's say 10. All right, that's pretty big, but whatever. I think we all get the point. Now I'm going to go to pipe. I want to do the same thing. I need this kind of beefed up so I can actually see. So 10 might be large. No, 10's good. 10's good. So symbol size multiplier, that's good. Show flow arrows, sure. I'm going to show you another little trick with these pipes. Let's see what I laid down. It should be whatever the default is. So I just double click those pipes. What size are we using in material? Looks like we are using a 6-inch. I'm going to just increase this to 8 just to show you that that's where you can do that. And instead of it being ductile iron, you can actually change this here. So this material library plopped up, and I'm actually going to go to PVC here. I'm going to be using PVC in this pipe, and it kind of just shows you all of the different notes here. You got your Manning-Zen and your Hazen-Williams. So in this case, we're using a Hazen-Williams of 150. Be cautious of your Hazen-Williams and all of your assumptions, and this is coming from an engineer. Make sure you have this solidified. Again, it's a roughness coefficient. No, so all of this is just scaled for now, but that is how you edit the physical properties, okay? So we got an 8-inch, and I'm assuming that this is going to be a 6. And you see how everything's just kind of black right now? I want to throw on some color because right now, I can't really tell if this is like an 8 or a 6. So how can I do that? You can actually go up here to Element Symbology, and you can right click, go to New, go to Color Coding. Now you can go to your field name, and I want to look for a size. I know that size is located somewhere. Alright, so you're going to go to field name, and I actually want to go find the diameter. And here we have it. We have diameter. You can select a range if you want, a minimum and a maximum range. Or, you can simply just start clicking in here. So I want my 6-inch pipe to be, I kind of like a little light blue here. And then I like my 8-inch to be, let's say, we'll go with like a dark blue. I kind of like that as a style. And as we can see here, if we don't have anything that's 6 or an 8, the above range color will be red. So anything above it will just be red. So I'm going to hit apply, and then voila. Now we got a color code system right here. Actually, I want to see the labels of these junctions. So I'm going to make this thing fatter. I'm going to go to junction label, edit. I need that height multiplier down here to just be bigger. I need to be able to see these numbers. I'm going to do 10. Okay, that does some justice there. You see that label pop up? So now I want to kind of offset it. I could always drag it, but I'm just going to do a simple Y offset and say 10 feet. All right, 10 feet's definitely not enough. So I'm going to do 50 feet. All right, now we're cooking with some fire, guys. So we got a reservoir set up that goes to junction 1 and junction 2. Now again, all a junction is something, it's a point in the pipe. Think of it as just a singular point that you're trying to examine in the pipe. Junctions have two main purposes, and one of them is to input demands into them. And what a demand is think of it as the service of the residential lot. So everyone's taking showers, using water to cook, right? So there's a demand on the system. Each of these residential lots has a unit demand that we're assuming. In this case, it might be around 300 gallons per day for each of these units. So we can convert that GPD, that gallons per day, to a GPM and actually input demands. Because when you're inputting a demand like that, that means that there's a certain flow in the system. Now, the other reason for junctions is when you have pipes that either downsize or when pipes are on a T. So in this case, I was just assuming that we had an 8-inch line going down this road, and we downsized to a 6-inch down here. So again, junctions can be T's, they can be reducers, or you can actually throw demand in there. Now, demand doesn't have to be applied into here. And an elevation doesn't even have to be assigned. In this case, I'm just going to assume that all of this is relatively flat, so I'm just using elevation of 0 for everything except this reservoir, because I want to see how this pipe system works with a certain static pressure in the system. So in order to set a static pressure, I need to set an elevation to this reservoir. Now, in order to go from PSI to feet, you can multiply by 2.31. So if I had 50 PSI, let's say, and we get 115.5. So now the system's going to have a static pressure of 50 PSI. And you can even leave notes in there. If elevation equals 50 PSI. I really like to leave breadcrumbs for my team, especially after I build these models, because that's a really big assumption there. Now, I am totally fine with how this thing is operating. Now it's time to throw some demands into the junction. Now there's a couple ways that you can do this. One, you can just double click the junction, and here we have either a demand collection or a unit demand collection. Here we can double click our junction, and here we have the property box. I'm going to go to demand collection right here. Voila, we got a little dialog box here. So you can actually enter in a baseline demand. For this case, I'm just going to assume that J2 will have about, let's say 10 gallons per minute. So we got 10 gallons per minute flowing through that system. So here we've already kind of compiled our model. So here we are. I mean, we've set up a model. We have a reservoir that's assuming a static pressure of 50 psi. We set it to an elevation, and now we got an 8-inch running along this road that downsizes to a 6-inch. So we pretty much have our model set up. And again, we assume that the junctions just had an elevation of 0. So we're just assuming just everything is just flat. So here we are, and we're actually going to go run the model. So now that it's running, now it looks like we didn't have any errors at all, which is pretty good. Up here you can see the time, you can see the flow supplied, which is 10 gallons per minute to the system. Now let's actually go check out the flex tables. What the flex tables show are results from the model, and in this case we have some pipe results that we can look at, or we can look at our junctions. I'm actually very interested in the pipes. So here we got the flex table for the pipe. Now let's see what we got going on in here. Okay, so the first thing I noticed is that we have some different materials that were called out. I actually want everything to be PVC, and it's easy enough to just go over there to that material, type in PVC, and now you are cooking with fire. Actually global edit all of these, and to do that you can go up to the column, you can right click, and I'm going to go to global edit, and now I can set it to whatever I want. So if I really wanted ductile iron, then now it's actually ductile iron. And again, you can change these Hayes and Williams. As you can see, so white boxes are the only ones that can change, while yellow boxes are actually either calculated or a physical property that you'll have to, go to in the program outside of this flex table. So here we can see we got P1 and P2. We have a scaled length of about 341 feet for that first pipe, 582 for that second. And we have 10 gallons per minute flowing through this pipe. And you can see that the velocities are actually, pretty low. One thing that I'm going to do is just increase this demand to show you guys how this value impacts the velocity. I'm going to increase this flow to like 50 GPM, and I'm going to run it again just to show you how velocity will change with flow. So I'm going to go up here and press compute, and then boom. So right now this thing's pushing about 50 gallons per minute, and the velocity through that is only getting up to about half a feet per second. So that's how you can check out the different pipe results here. But now I actually want to see what's going on in these junctions, so I'm going to go to the junctions. You can see that the pressure is 50 psi. And again, this is cool because again, I showed you guys that I was setting a static pressure. So this whole pressure in this system is just straight 50 psi. Now I'm having trouble reading the label for these pipes. So what I want to do is I want to make this bigger. If you all remember, you can go to element symbology. You can go down here to edit. And I'm going to multiply this thing by like 15. Yes. Okay, I want to be able to see it. Now we're going to change that Y offset. I think I need like 25 feet. Okay, maybe not. I might need 50 again. All right, perfect. Now I want to show you how to set up different labels in here. So I just ran a model, and I can go over here and right click pipe, and I can do new, and I'm going to do annotation. Now you can pick whatever annotation you want of this pipe, whatever different results, physical properties. In this case, I actually want to show the velocity. I want to quickly identify what the velocity is. Now I'm going to do another multiplier, do it by 15. And you can see that it's kind of, coming on the pipe again. So let me actually offset that one down -50. Awesome. So this is actually looking really good now. So we've identified how to set up a model with a static pressure, how to change the pipe sizes, how to kind of, get something a little bit more neat looking to examine. And now we've kind of showed how we could add the different labels to this model. So just as a recap, I showed you guys how to set up a static pressure of a system. In this case, we have an existing water main out here on the road that's 50 psi. So we converted that to a static head here, set the elevation of this reservoir at 115.5 feet. We have an 8-inch pipe along here, and we know because dark blue is the 8. Now let me actually show you something as I'm kind of talking about it. I want to get a legend of these pipes. I'm going to right click this diameter color wheel over here because this means that it's all color coded. I'm actually going to go over here to insert legend. Now it's going to ask me where, and you see it's kind of tiny. We're going to right click that and we're going to scale it up here, and then voila, I can actually move this over, and I can clearly see that any light blue is a 6-inch and any dark blue is an 8-inch. So that's some pretty cool stuff here that we can do, and we can make fun maps. You can't really see this right now. I don't really want to show the aerial anymore. Remember that your background layer is right here. You can turn this off, and now this is how it looks. I can start zooming out and in and all around. In the next video, we will dive way more into scenarios and alternatives, and then we'll examine a water main that has fire hydrants on it. So we'll do a fire flow scenario and a hydraulics only scenario. So if this content was helpful, I hope you hit the subscribe button. I hope to help more other land development engineers out there. And let me know in the comments what else you would like to see, or if there were any unanswered questions. Thanks everyone, and have a good day.